Optical LAN. My name is Joe Cook, and I'm a member of the APOLAN Technology Committee. I'll be your moderator today. Before we begin, I'd like to cover a few housekeeping items. First of all, each of your audio has been muted for everyone except for our presenters and panelists today. So if you have any questions, please submit them via the question feature on your screen. We'll do our best to get to those throughout the presentation this morning. We may take those in rhythm as they come, and we may also save some for the end. Secondly, the presentation slide deck will be emailed to each of you at the conclusion of the webinar. It includes your information about APOLAN's benefits and resources and contact information and other questions that may arise throughout the day. With that, I'll go ahead and get started. I would like to mention that slides 2 and 3 are basic housekeeping items. Our antitrust and no solicitation policy. We'd like to ask you just to review those if you would. I'm not going to read that to you. Each of you are more than able to read. And then our legal disclaimer. Our legal disclaimer, of course, is just one of those little things our lawyers tell us we have to say. So I want to make sure you're aware of all of that as well. With that, I'd like to introduce myself, of course, Joe Cook, Business Development Manager with Optical Cable Corporation. Robert Basile. Robert is Director of Global Market Development for Corning. He's a Technology Committee member with APOLAN. Scott McIsaac. Scott's the Technical Account Manager for Telabs and also a Technology Committee member here on APOLAN. And Matt Miller. Matt is the Global Networks Leader working for AECOM. He's the Technology Committee Chair with APOLAN. All these guys have a profound amount of experience and lots of great information to share with you today. I'll go ahead and start this. This slide gives us a quick look at the evolution of optical LAN, its foundation as passive optical network technology, and kind of the timeline of some of those events. PON isn't just a buzzword, is what I'll tell you. It's a proven technology. It's field tested. It's standard-based architecture that's been refined over decades. It's widely deployed. It was originally built for carriers. Benefits like low maintenance, cost efficiency, and future proofing all translate directly into enterprise environments today. You can see the evolution beginning around 1998, APON. Everybody remembers the ATMs, BPON, broadband, gigabit, fiber to the home, and those sorts of things all follow that track. And so we're talking about technology that's over, well, I guess almost 40 years old now. So very, very reliable resource. This slide shows a little bit about the evolution of optical LAN's timeline, highlights, I guess, really a lot of things packed into this visual image, if you will. The key takeaway is that fiber is fundamentally a game changer. Unlike copper, fiber can cover much longer distances without signal degradation. It does so with a lot less equipment. That reduction in active gear translates directly to a simpler architecture for you and your clients, reduction in space requirements, cost savings, major cost savings on CapEx and OpEx as it relates to the design. And whenever you see how this plays out across the applications, horizontal and vertical runs, even campus-wide deployments, it's just a really, really good resource to consider. You can see the building backbone is about 90% optical today in most of your designs that you're working on. Horizontal LAN is still very heavily copper, but it's a growing space for the fiber deep and the fiber to the edge, or optical LAN as we refer to it. Lots of reasons, all the bandwidth hungry devices that are in your smart communities and larger campus deployments are driving this evolution. So a little bit about this timeline. You can see some key highlights there, but optical LAN has come a long way. We saw momentum in the early 2000s with bend-in sensitive fiber. Um, Passive optical LAN was introduced into early installations that came online, DoD. First major installations were done in hotels, universities adopting it, major airport installs, major sports venues installs. More recently, we've seen optical LAN begin to play a critical role in net zero initiatives and DoD deployments. And so it's scaling to meet the demands of Wi-Fi 7. DAS is another driving factor. And so there's a lot of technology that is not just emerging, it's established, trusted, and rapidly growing. So anyway, with that, I would like to remind you to submit your questions. Don't forget to send those in and use the Q&A button on your screen. And I'm going to turn to our panelists now. And I'm going to ask Matt. I think I'll start with you with this one. Which vertical markets were the early adopters, and who uses optical LAN the most today?
Joe, thanks for having me on here. This is as I looked at that timeline, I was kind of taken aback at how long we've all been doing this. We got a great set of panelists here that we've been working together for quite a bit. So, as we look back at the early adopters, that timeline just felt even more real for me for some reason. But to answer the question, about vertical markets being early adopters, it was government. We worked with government entities that were traditionally doing fiber to the desk, but they were doing multi-mode fiber to the desk in the early days. So they had security requirements that demanded fiber, but it was, as we probably all know, it was not commonplace at all at that point. And putting multi-mode fiber to the desk was just incredibly expensive, right? You needed fiber optic network cards and fiber switches, which were just, the pricing was just astronomical on those devices because they were very niche in their requirements. So they were definitely the early adopters, but and they continue to use the technology quite a lot today. We have a number of customers ourselves in the government market that they use this technology, so they've been steadfast throughout. But we've seen tremendous growth with other vertical markets. Specifically, hospitality has been huge, right? The hotel chains have just really connected with this technology because they want the money, the cost savings. They see that, they see the longevity and not having to go out and do renovations to their properties to modernize connectivity once they have the fiber in place. So they've been huge in the adoption lately. The other one is education. And I think we all know why that would be, right? But it's both K-12 and higher ed that we've seen it, right? And in K-12, we know budgets are a major constraint for them. So having the ability to implement technology across older buildings that are not easily renovated and being able to provide high connectivity for demanding environments, as well as higher education, right, where they've got these huge campuses and long distances to cover. It's a slam dunk for them as well. So that's where we're seeing it today.
Wow. Well, thanks for that little bit of an overview there. So you mentioned long distances. Could you just give me a little bit of an example of what some of those distances might be?
Yeah, that great following. Yeah, the technology originally being for fiber to the home, like you spoke about earlier, we've got an easy reach of 20 kilometers, right? That's the standard. So going 12 miles or 20 kilometers is no problem for this technology. So when we look at a higher ed campus or even a government campus, even K-12 school districts, right? They can potentially be held within the footprint of that 20 kilometers very easily, right? That means that we could have one piece of electronics, that OLT at the center of the whole network, centrally located, or maybe two of them for redundancy, on one campus and be able to serve thousands or tens of thousands of users quite easily within that 20-kilometer reach.
Wow. Thank you. Robert, why are we just now seeing adoption of this technology from your perspective?
Yeah, I appreciate the intro, Joe, and just your opening comments. I think you covered some of it as we kind of looked at the building and some of the market trends and just market saturation that was out there. I don't know that we're just starting to see the technology from a full view, right? We have kind of 100% optical, in the backbone. I like to take this all the way back to early AT&T Bell networks, right? I mean, we realized that copper and just a twisted pair phone line wasn't gonna do it, right? So we quickly went, fiber to the node, fiber to the pole, fiber to the curb, fiber to the home. If you take it over to the business space, we went fiber to the business, quickly fiber up the riser, getting rid of those big 288 blocks everywhere. What we're starting to see now, though, is that changeover of that horizontal market. And I always like to think that, that the fiber and the optics have to drive out there further to get that user experience that everyone expects. So right now we are at the, Wi-Fi and wireless technologies are no longer a nice to have. They're an absolute must. If you go back 7, 8 years ago, we still always had to plug in, right? People didn't necessarily expect to be connected. And so Wi-Fi is becoming one of those critical or kind of killer applications that I call it, as it moves well beyond gigabit speeds into 10 gigabit, 40 gigabit speeds. As we start to talk about Wi-Fi 7, it's putting all new demands on that network, right? We're having to drive that optical capability out there significantly deeper to pick up all of that additional capacity needed by the users, not only the individual users, but the many connected smart devices that they're bringing onto the networks. We're just starting to scratch the surface right now on AI, right? It's the big two-letter buzzword that you can't get away from in the news every day. Obviously, that's impacting, large buying decisions today. It's starting to impact design decisions in building. And I think it's largely because we don't even know what its impacts will be yet, right? We haven't seen that killer AI application. We can generate pretty fun images and get quick answers to questions, maybe write some code, right? But we haven't necessarily see that thing that really starts to pull on these networks that we're building. So to sum that up, I think what we're seeing right now is a new age of like that killer application, how people use these networks. And it's ultimately driving that same trend that we saw in the outside plant that's now 100% optical. We saw that same trend in the riser that's now 90% optical. Now we're starting to see that trend move out in the horizontal to pick up that last leg to fully enable the edge of the network with not only bandwidth, but power as well over these technologies.
Wow, that's pretty impressive. So you mentioned power as well. So you can power devices this way as well. Is that what you're suggesting?
So it's a nice little misnomer, right? I mean, optical fiber. Working for Corning, I can tell you we have some of the most brilliant researchers and scientists in the world in Corning, New York. I will tell you, for no shortage of effort, I've seen them try to power devices over the glass, but we're not quite there yet, without probably a nuclear reactor at the end of it. So ultimately, what it turns into is really the advent of hybrid cable technology. That's where you'll typically have an optical fiber, and then inside of the cable jacket, you'll have DC power delivered as well over copper conductors. That hybrid technology allows you to bring a lot of the benefits that we've enjoyed with copper or category cables over the years. One seamless cable to the edge that's going to give you all the bandwidth and all the power that you could ask for. But more importantly, it's going to allow you to critically back up networks and start to more centralize the distribution of those networks. Obviously, there's quite a few benefits to also being able to locally power devices when that makes sense, and you have the ability for kind of local backups and more distribution. But it's really that mainstream adoption of a hybrid fiber that's allowed these networks to not only pick up all these future bandwidth needs, but also plan for the power needs of the future.
Awesome. Thank you, Robert.
Sure.
Scott, what size installations are you seeing optical LAN used in? Is there like a breaking point? Is there a critical number, or is it just a wide open playing field.
Good morning. Yeah, thank you for the question. I think when optical LAN got started, it was definitely more contained and constrained. There was always that question of where's the cutoff point, where's the real TCO, how big did it have to be in order to get to the size you want. But as technologies changed and lots of innovations went into the whole plan, or like Bob mentioned, having better fiber out there, different technologies to support the power. Even Matt's comment on distance at 20 kilometers, but being able to go beyond that with some technologies to 30 kilometers just using PON, never mind combining transport Ethernet with PON, reaching out 80 kilometers or beyond. We're now seeing deployments scale from small mom and pop gas stations to full blown installations for, like Matt had alluded to, the campuses for colleges, for universities, for healthcare. I mean, the dynamics just grow and grow and grow. I mean, one of the largest deployments in the globe today, I think, is the Department of Energy, Sandia National Labs, where it's a multi-acre campus, and they've got hundreds of thousands of Ethernet deployments across an optical LAN network. It's growing constantly, and then adding to these networks once you've built it. And I think everybody's kind of keyed in on it. Once I build that infrastructure, I built a fiber highway to run things on. Growing and scaling these networks is simple. I don't have to overlay again and keep rebuilding or keep adding a ton of capex into a network to grow it. It's very easily scalable by simply either adding another device off an existing splitter or port, or simply adding another wavelength to get what's that next ITU standard. So, as you had mentioned in the timeline, BPON to GPON to XGS PON to next generation PON, what is the limit in the bandwidth? Fiber's limitless to what we know. It's all based on the equipment on the end. So I can go as small as the mom and pop gas station up to entire cities. Smart cities being deployed today could be a single OLT like Matt described for the schools, supporting the entire town or the entire airport, which is kind of a small city within a city kind of thing. Cruise lines. Oh my God, everything, it's just a floating hotel now. So yeah, it can be deployed anywhere. I guess the question really is, where can it be deployed?
It's a good thought. Well, thank you. Appreciate that response, Scott. This one's for all of you guys. Just feel free to chime in, but what are some of the funniest arguments that you've heard against optical LAN?
Yeah, I can jump in to start us there. I saw Matt on mute yet smiling, so I know he's thinking of a good one. But one of my favorites, I kind of have two that I'll lead with up front. One of them is a bit more humorous. So the more serious one that I've heard, and this is dates back a decade, but you can't transport data over fiber. Always one of my favorite ones. The world's networks are distributed on optical fiber today. And I think, all of our comments, Matt, Scott, myself, I mean, they all lead up to, we're taking these optical technologies into what I would consider to be one of the last horizons right now, which is to the horizontal or the network edge, right? So always kind of a humorous one when I hear that. Obviously optical is how some of our largest data centers in the world drive. It's how outside plant drives. It's how our future in-building networks will be driven. But more on the humorous side, I would say one of my favorite ones was I met with a CIO, and I won't even name the area of the country for certain reasons, but he asked me what would happen if he walked into his head end and hit the head end with a bat. Always a great one for me, because my response was, what would happen if you went in and hit your traditional network switch with a bat? But on a serious note, I think it speaks to, just some of the things that we run into industry around, nuances of a unknown or a newer or just a less familiar technology. We have education that we constantly try to do out there through APOLAN, through the consultant basis, through the integrator, through the customer basis, right? And on that note, while it is humorous to say what happens if I hit a piece of electronics with a bat, there's resiliency strategies, right? You can have, dual head ends. You can have A/B path redundancy heading out to the edge. You can build these networks significantly more critically backed up than you can in a traditional cabling world, really based on category cable, right? You get out of this mode of 100-meter distance limitations of the cable. You get out of this world of, well, I must build this type of pathway or this type of rack or cable tray or conduit or whatever it may be, right, to support these pieces. This technology, I always like to say, optics allow you to, design your network around your building versus your building around your network, right? And that kind of flips design methodology on its head that we followed for 20, 30 years, right? It gives that flexibility and that capability for the future.
Yeah, I'll
Wow.
tail on what Robert said there. And it even reminded me of one, that we still hear today, and that's that fiber is very delicate, right? People imagine that you have to like handle it with these white gloves and be very careful when you touch the fiber. But as you showed in that timeline, I think it was 2007 that bend insensitive fiber is. And man, yeah, I keep feeling old every time I think about that timeline. But yeah, we're coming up on 20 years since bend sensitive fiber was introduced, right? And so now, I mean, we see installs that that there's just no failures on the fiber, right? We even see where sometimes copper is installed alongside the fiber for certain requirements, and that gets damaged, but the fiber does not because it's got a smaller bend radius and higher tensile strength and all those great things. So it's funny that we still get that argument, but I was going to bring up one about VLANs, and it's so funny. I don't know where these rumors come from, but it's fear of the unknown or something that people just latch onto these ideas. But early on, we were getting this rumor circulating that you could only do, I don't remember if it was like 10 or 12 VLANs for the system, some sort of ridiculously low number. And the funny thing about that is that not only is that just plain wrong, you can do the normal 4,000 whatever VLANs on an optical LAN, but you can actually, because of its heritage in the carrier market, you can actually do double tagged VLANs. So you can actually put 4,000 VLANs inside of all 4,000 VLANs. So you can actually get on the order of magnitude of 16 million VLANs on the system for a lot of these manufacturers now. So yeah, not only can we do more than 10, we can do millions potentially. So those are a
Wow.
couple of them.
Thank you, guys. Scott?
I don't really have any funny stories. I think that most of them are just kind of ironic and just like the pushbacks that people seem to have, I think is more because they don't understand what's available or they're afraid of change. And there's really not that much change, right? Everything's an Ethernet connection off the end device supporting every other end device or customer piece of equipment that needs to go on it. Or it's all my people are Cisco trained. So that means they're only smart enough to work on Cisco stuff. I think it makes them smart enough to work on anything, right? And this is a much simpler technology. And we don't really, compete with Cisco because Cisco does LAN technologies, right? So some of what, we do from different manufacturers is support what they do and make it more cost effective, more flexible, so that the money can be spent on those core type applications where they really get their biggest bang for their buck. So it's looking at, interoperability. Oh, you can't work with this. I can't mix and match. I don't know what devices can't work over optical LAN networks. There's just so much new technology and applications coming out that demand. Bob hit on it with Wi-Fi 7. So all the cameras and everything that are being deployed, why can't I support that? right? Latency might be an issue for some particular applications, but in general, it's a much more flexible deployment. Or even trying to reach that far outbuilding somewhere, or maybe the baseball field that you now want to have cameras on. What would make more sense, to put a cabinet in somewhere and have to put in HVAC and a whole bunch of active Ethernet gear, when you could just put an ONT or a media converter at the end of a piece of fiber? So the cost of growth and scale. So I really think it's just people just don't know what they don't know. And even working with some partners over time, there's a lot of confusion. It's kind of like drinking from a fire hose when you introduce new terms, but really everything's a port is a port is a port. So the handoff to the customer is still the same. There's no change for the customers, but they all think it's going to be dramatic. Oh, this is bad, I can't do this. Or there's no protection anywhere. We've had scenarios where customers might have a pipe burst and take out some of the optical LAN equipment, but it's switched over to another geographically diverse location, like Bob had mentioned. Put equipment elsewhere, and the system just switches over, and the customer's not aware that anything ever happened. Nothing ever went
Mm.
down. I think their biggest fear now becomes they don't have to address issues on a daily basis or see what the problems are. So they think, well, that's a problem because I'm not in it every single day. I don't have to watch it like a hawk. I don't have to keep putting out fires. My system just runs. So it's almost comical from that aspect. I go from having to have so many people dedicated to just watching for alarms to, how come I'm not getting any alarms?
Mm.
Joe, I'll give you one more that kind of reminded me. We teach classes at Bixby on how to implement this technology, and we've even had people stand up in that class and say, "This just isn't going to work," right? Like as if it's whenever this first one gets installed, it's not going to function. But I mean, we were getting that argument even 10 years ago when, hundreds or thousands or millions of end users were already relying on the technology daily for their needs. But people, to Scott's point, that there's this fear of the unknown. They don't realize not only will it work, it does work just fine for lots of folks.
Right. That's great. Thank you, guys. Matt, what early days of technology? Let's go back a little bit. You keep talking about how old you feel. Let's challenge you a little bit. What were the biggest technical challenges and selling challenges in the early days of adoption?
I guess I brought that on myself, didn't I?
Yeah, yeah.
Yeah, I mean, some of the things we just talked about were certainly some of the selling challenges, but I'll address on some technical challenges, because I think the root of some of the rumors we heard were based in early deployments, right? And those just went on forever. Again, as we talk about where this came from the carriers bringing fiber to the home, that's what the technology was designed for. And so there's certain things that they do that enterprise doesn't do, or vice versa, right? There's certain features in the enterprise that we need that the carriers don't necessarily require. So when we first were putting these systems in, we were running into issues, certainly. The easiest early one was there was no PoE on the ONTs, right? For fiber to the home, there was no requirement to bring PoE because routers aren't powered by PoE typically. So we had to work with the manufacturers, but they quickly recognized that was an issue, as we went into the enterprise market, and every manufacturer quickly jumped on that bandwagon. And obviously just about every ONT you can buy these days supports PoE, especially for the enterprise market. So yeah, we ran into things like that. The other one was the security. The innate security of the system actually prevented user-to-user communication, meaning from one ONT to another. By default, that was blocked. The carriers don't want you to be able to attack your neighbor or surveil what kind of communication is going on with your neighbor's ONT. So they required that all the traffic go upstream and go through their filters before it could return back downstream. So sometimes it was just a simple matter of enabling those types of features on the systems to actually allow normal switching traffic. It's not like it was some sort of major technical hurdle, but it was just a feature that they had not wanted or had the need for previously. So we had to work with them on those. But now we find that the systems out there today are very robust in their feature set, and now often beating the traditional manufacturers in performance and usability. So it's kind of interesting to see SD LAN or SD anything being defined or being shown as a new technology, right? Software defined networks. That's kind of funny because that's how POL has traditionally operated, right? As a software defined network, meaning all the ONTs are configured by the OLT. We don't have to log into those individual devices. So we kind of flipped the script on them. But on the selling challenges front, I'll echo what Scott said, and that's fear of the unknown, right? People just aren't familiar with the technology sometimes. That's obviously evolved over the years, but now we're seeing people know the technology, but they're still a little afraid of it. But as soon as they sit down in front of it and they see, oh wait, it's just VLANs and PoE and QoS and all the things I know, it's just a user interface difference. That's really all we're talking about here. As soon as they see that, those fears go away.
Awesome. So we had a question come in via the chat. If you want to go ahead and take that, Bob.
Yeah, sure. Let me bring that up real quick. So the first question that came in is, how long do you think big traditional LAN vendors like Cisco, HP, et cetera, will resist till accepting reality and start offering optical LAN solutions? So I certainly do not work for those companies, but I can speak from my perspective at Corning. We work with those companies in many markets today. So again, we've seen their adoptions in the long haul, the outside plant, the campus, the data center, right? We see those regularly happening. I think personally, one of the pieces that we measure in the market is ultimately, where is that threshold of applications that kind of forces people's hand to change how they're delivering optical infrastructure today. And so with that said, I think one of the pieces that will drive is again, those killer applications, right? So Wi-Fi 7 will certainly be one of those applications. It has front haul speeds of which are the radio speeds advertised as high as 40 plus gigabit per second. You're simply not going to deliver that over a single Cat6a cable for anything really beyond 30 meters, right? Which kind of becomes unapproachable. So I think what you're going to see is many of the edge applications that concentrate capacity, user bandwidth, different types of devices like Wi-Fi. I think you'll start to have to see that tip over to match front haul radio speeds with backhaul, right? Which is kind of the network speeds that drive those devices. So I think that's an area that you'll see many OEMs in the market keep their eye on. I think a little bit more directly to your question, you don't necessarily see those larger names in the networking market offering PON technologies as an example. But it's also kind of a bit of a good segue, right? Where while they may not offer PON technologies, they absolutely offering optical Ethernet technologies, right? And that's the other area that we're talking about, is that point to point may make sense in certain applications. Point to multi-point will make sense in applications. I think what it is kind of a heritage of where the business has been, where their traditional markets have been, and how they've approached things. There's many things that have to adjust in an ecosystem to allow for a major structured cabling change. I'll speak for some of the guys here with me on the panel. I mean, it's been a 20, 30-year conversation with folks like TIA, folks like different standards bodies that are out there, right? To kind of get these different standards documents like 568 adjusted, right? To start allowing for new approaches to these pieces. So we've seen a lot of those barriers come down over time. And I think that's one of the things that's starting to open the gap for more vendors, different OEMs to kind of come in from the network electronics side, the application side, and really start to allow for these new types of infrastructure to ultimately, unlock. So hopefully that helps answer the question a little bit with context there. Welcome any of the other panelists to chime in as well.
I think that's great. And based on the question, why would Cisco or others do a PON technology type thing? I think some of them have, right? So there's large companies besides Cisco that have partnered up with other companies, bought their product, and they resell it, because you need to have the tool in your tool bag. Anytime you're trying to answer an RFP, to Bob's point, it may not be the selected technology that they want to offer because of their cost structures and where they can make real profitability. But if the RFP demands other technologies in that RFP, other than just switched Ethernet type services, then I have to have something to at least keep my foot in the door. So we've seen partnerships happen across the marketplace where everybody has some type of media converter that they can do and get that longer reach and not have to deploy a full HVAC enclosed environment to support active Ethernet gear, right? So you want to keep your name in the game, you have to be able to be flexible. So I think we're seeing some of it. It just may not be their first choice of what they want to sell, right? But you have to kind of adjust to what the application is. And I think that's probably the bigger thing. As more applications get identified, the Wi-Fi 7 gets mentioned a lot because of the amount of bandwidth that it's letting you bring onto the network. It's really just a bigger door, letting more people on at higher speeds into the network, and you're getting more wire-like speeds over the air where you didn't before because of newer technologies. So that's driving more technology changes. To even Matt's points, how do I get there? What's it going to take? So this whole evolution of the local area network is going to go way beyond just what optical can do for us. There has to be massive technology changes across the board. And if any of us just sit back on our laurels thinking, oh yeah, we got it covered, then we're all in for a rude awakening. You think back to early fiber technologies. What were we deploying first via fiber to customers? It was 1.5 megabit of bandwidth because it was better on the telco's 04 rate, the repair rate. I didn't see fiber decay like copper did, but that quickly went to 1 gig applications, to 10 gig applications, to 40 gig, 80 gig, 100 gig, 400 gig, terabit. So even the RBOCs are offering terabit speeds to their customers. And now to take it from the WAN side into the LAN side, you want to be able to offer that same kind of technology to extend it right to the desk or the end user device, wherever that may be.
Well, I appreciate that response from each of you. I think we have another question. Matt, do you want to take a stab at that?
Yeah, certainly. Yeah, the question was about where the technology has gone, and are we seeing, was there a compromise in using PON versus enterprise or vice versa? And it's kind of interesting as the technology has matured, right, from being a carrier technology to now a very enterprise focused technology. Now we're seeing that if you're not doing optical LAN, you're compromising, right? There are so many architectural advantages to the technology, and I don't just mean building architecture, but network architecture, right? So the fact that that we no longer have those distance limitations means that we can fundamentally change how we design buildings, right? We don't need telecommunications closets in order every 100 meters or so in order to provide connectivity within a building. So now we can fundamentally change how people design buildings and not require all this dedicated space potentially. So so it's changed the ball game in many ways because of that. And now with all the enterprise features built into the technology, that all those early technology challenges and naysayer comments, those are gone away, right? We still get the naysayers, right, because they're afraid of the technology. But now you can get the best of both worlds, by going with optical LAN.
It's great. Great answers, great questions. Uh, you know, this is one that we didn't really talk about, but I'd like to present this to you guys because I feel like this is relevant to all the participants. Optical LAN is a converged network where we're collapsing disparate networks throughout the architecture, and we're eliminating a lot of that mid-span architecture that's so commonplace in a local area network. Talk a little bit about the types of networks and the types of technologies that are being converged into these platforms and the reliability of the solution that's being deployed. Whoever, all of you.
That sounds like a Robert question to me.
Yeah, that's good.
See, I should have kept on mute there. I figured Hero was coming my way. So if I follow you, Joe, I mean, I go to kind of car analogies with this, right? You don't necessarily start with designing the new car, right? From the Kia all the way to the Ferrari or the dump truck, right? You start with the highway. And that's ultimately what the infrastructure is. It is a highway to get, bandwidth and power out to our edge devices. And so, I have a fundamental belief that if you deploy bandwidth and power to everywhere that is going to ask for it, there's no such thing as being future proof, but you are absolutely as future flexible as you possibly can be. Some of the changes that we've seen happen in these optical markets, Matt and I used to operate in a world of XFPs, right, and burnout and things like that, right? People expected to go to single mode fiber. You were going to be in a couple $1,000 transceiver, right, to enable it. We now see those SFP plus form factors. We see 10, 40, 100, 400 gig type speeds. 10 gig is so commonplace today. You see transceivers, $50, $60, right? So it's kind of changed the game on that adoption, and it's allowed more things to kind of drive onto that highway, if you continue to follow the analogy. And so my point is we've seen, cellular technologies convert from analog to digital, right, to fully IP. As they were analog, they had the ability to use dedicated strands of fiber that were right inside of the network, to join. As they converted to be digital or IP, we now see them straight, Ethernet transport in many cases, right, with standard IEEE based packets, right, that are moving across these networks. We see a fundamental shift as well, really, in AV and broadcast networks, right? We're starting to see strands of fiber left, or again, fully IP-based distribution, right, of audio and video across these networks. So, again, my view of it would be that, you build the highway, you construct the highway in a way that it can carry anything and everything that wants to come down it. If we get a new, slick, cool technology tomorrow, we're not going to be limited from that infrastructure. I always, I'm one of those geeks out there. So when I walk in and I take a look into a cable tray, right, I see Cat 3, Cat 5, Cat 5e, Cat 6, Cat 6a. Maybe I'm over in Europe and I get a little taste of Cat 7, right? We're talking about Cat multi-mode, coax, twisted pair. You have all these different technologies or all these different cabling infrastructures for carrying various technologies. Optical fiber is the least common denominator, right? If I'm able to drop a little middle school math on you, it's what everything comes down to, and it's where things center around. So, it's kind of an ironic business to be in, as a optical provider, right? Because ultimately, the more we position, the more we help people deploy these networks, the more we kind of put ourselves out of a job unless they're building new, right? You get an opportunity to put the right infrastructure in. And I'll kind of cap it with, in our timeline, Matt's talked about feeling old. I think this predates all of us, but, just the invention of low loss optical fiber. If you had the foresight to put in, a single mode fiber back in the early 90s, you still have the most future-proof infrastructure that you could possibly ask for today out there and deployed and kind of carrying your applications. There's been innovations, right? Like bend insensitivity and low water peak and things like that. But overall, right, as the transceiver cost has come down, we've allowed a lot more things to kind of come onto that highway and fully utilize that optical investment that can kind of get reused for these different pieces over the years. So a lot there. Obviously, a lot of passion in the comment, but appreciate the question, Joe.
I'll
Great
even add
answer.
on to that. Everything that Robert said is correct. I agree with him completely. I see it as, you're going to need connectivity for all these devices throughout your infrastructure, right? So plan for that accordingly, right? Put that fiber everywhere you can imagine needing connectivity for the future because of what Robert talked about, right? That it's going to serve you for the foreseeable future and beyond. And use it for what it's good for, right? Fiber is the superior technology for connectivity. Copper is the solution for power, right? Not for connectivity. It's good for power, but not as great for connectivity. So put that stuff where it is needed, and you won't be going back in the future to rip open walls and add connectivity later.
I'd love
Great
to add
answers.
to that as well. Again, both great responses from Bob and Matt. Especially with the highway analogy that Bob brought up, people a lot of times think fiber, it's a single connection. It's a single mode connection. I used to have a separate transmit and a separate receive in optical networks. And again, we were doing very small, low data rates of 1.5 meg because it was king. No one was ever going to need more than that. But, as the prices came down, to Bob's point, as things got more cost effective, bandwidth became more readily available. Even in the telco space, to go from a 1 gig EPL being expensive and then coming down in price, the next generation became 10 gig wave services for the exact same price. So as a customer, they're thinking, well, what do I need 10 gig for? Well, if I can get it for the exact same price as 1 gig, why wouldn't I take it? I'm getting a bigger bang for my buck. I can buy a Cadillac for Kia prices or whatever you want to use for an analogy there. But the convergence of technologies, like you alluded to, Joe, it's not just a single lane on the highway, right? That's a multi-lane highway. And that multi-lane highway gets bigger and bigger and bigger every year as technology changes, just by changing the equipment on the endpoint. So you built that infrastructure, to Matt's point, get it everywhere because I can put anything on it because the technology will keep pace and create the new ways of using it. So now any type of media converter at the end can then blend the coax that Bob mentioned, the CAT-X cable that's needed for the other device without distance limitation, with all the new technologies that are coming out, the Wi-Fi and the camera. I mean, everybody's putting cameras everywhere now. Never would have thought there would have been cameras in every school project that you're doing, but every school wants security.
Yeah.
So to have those things, it's a separate VLAN or it's a separate wavelength. So I can still keep them as separate networks, but treat it as one physical deployment and still have my separation of technologies. So tons of
Wow.
flexibility with this.
Thank you, guys. We're out of time for questions, and we need to move on. But if you are seeking educational credits, there's going to be a poll that will pop up on your screen. We're going to need you to respond to the poll. I'm going to show the slides here, but the poll will be displayed for you. We're going to ask you to go ahead and respond to those. And whenever you do that, we'll categorize that on our end, and then we will issue your credit to you. So I'm going to just go ahead and ask you to do that now. We're going to take a couple of minutes here as we wrap things up and move on and allow you to do the poll. But the first question that you see there on the screen, and I think the poll has probably popped up on your end as well. I'm not able to see the poll on my side. What device is placed at the network access endpoint?
I know.
Well, they said I can't vote on these, so.
Yeah, me too.
Don't let them cheat, Scott.
What? Who's cheating?
Network terminal. You guys
Everybody
are all good
gets this mixed
students.
up in the early days, so I just want to say if you got it wrong, it's okay. The OLT ONT acronym is a confusing
Yeah.
one. That's why we picked it as a question.
Right. Next question. What was the first portion of the network to go optical? It's the backbone vertical, horizontal, or patch cables? Bob, I think you know this one for sure.
I don't know. I'm gonna avoid answering. I wanna be shameless. All right,
Backbone.
we did pretty good there. That wasn't bad.
Yeah, very good. Third question. What years was passive optical LAN introduced into the enterprise space? This is a little tougher, maybe.
I feel like everybody's looking at us now and saying, how old are those guys?
Yeah. 2006 to 2008 timeframe. All right. Well, I want to say thank you to Matt and Robert and to Scott for their participation today, volunteering your time, sharing your expertise, and providing the history and evolution of optical LAN. We do encourage all of you who participated to review APOLAN's information on these ending slides. We'll be sending you the slide deck, like we said, and you'll have the opportunity to learn more. We're always looking for new membership and opportunities to help with the adoption of this great technology. A little bit about APOLAN's mission is to accelerate the adoption and evolution of fiber optic local access networks for enterprise. And if you are curious about joining or seeking more information, you can visit our website, connect with us on all the various social media platforms. There's an email address that will be provided to you in the slide deck. And if you are submitting for learning unit credits, those that provided your AIA number during registration, if you completed the poll, you'll be receiving a notification about that. We've also submitted this and requested CEC credits for other disciplines and professional levels. If you're interested in being notified once that determination is completed, email director@apolanglobal.org. And on behalf of everyone at APOLAN, I just say thank you for joining us, and we look forward to seeing you again on a future webinar. Have a great day.